Okay, this next question, this is the one about Wanda driving 250 kilometers north at 100 kilometers per hour, stops for 45 minutes to have a picnic, drives 100 kilometers south at 50 kilometers per hour. The point of this question is to illustrate the difference between speed and velocity, average velocity, constant speed, constant velocity. They're basic concepts in physics. So Wanda starts here. I'm going to label her. X represents position. It represents horizontal position, just like the x-axis on a graph is a horizontal. You have the y-axis, sometimes the z-axis. Then yeah, that's where the x comes from. But the letter X all on its own represents a point. And now she's moving horizontally from that position point. She's going to move north. So she's going to travel north. So that's the direction. I'm just saying that way's north. And she ends up 250 kilometers north here. So there's this point right here. And that is, I'm going to call that delta x1. That's the difference between those 2 points. All right, delta, remember, is the difference between 2 places. And so from here to here was 250 kilometers north. To precisely describe a vector, and displacement is a vector, you need the magnitude, the amount, the unit, kilometers, not miles, kilometers, and the direction. Okay, so she does that in a time period, what I'm going to label as delta t1, the time it takes to travel that, to change your position. That she does that. I'm going to have to find that out. So hold on, I don't know the answer to that yet. Okay, and then she stops. So she stays there. She's at rest. Then she's at rest. So at rest, she's not moving. I'm going to call that delta t2. As for 45 minutes, now I'm going to work in hours because the speed at which she traveled up here, I should have written that down. The speed at which she traveled, and she's traveling in one direction, so that's also a velocity. That is, what did I say, 100 kilometers per hour. 100 kilometers per hour. And again, that is north. So I'm going to leave this in kilometers and hours. Well, okay, so she does that first part. I'm going to calculate the time in a second. The second time is 45 minutes, which is 3/4 of an hour, right? 0.75 hours. And then I'm just going to use a different color for the heck of it. After that time period, then she travels down here, and it says that she travels 100 kilometers south. And I'm going to put that as XF for the final position. And that is a delta X. And I'm going to use a 3 here, because this is the third leg of the journey. This one over here, the second leg, she doesn't go anywhere. She's at rest. And then this one is 100 kilometers south. And she travels at a speed, in this instance, she travels at a speed and a corresponding velocity of 50 kilometers per hour. 50 kilometers per hour south. This corresponding velocity during the second segment is, of course, 0. She's not moving. Okay? So there's all that information. I need to grab a calculator. So I'm going to have to solve for the time it takes to go 250 kilometers at 100 kilometers per hour. I can do that on my head, and you can also, most likely. We're going to need that time eventually, so let's just figure it out. You know that basically velocity and average velocity, now this is a constant velocity from here to here. She's traveling at a constant 100 kilometers per hour. If you're traveling at a constant velocity, and you don't change direction or do anything else, you just travel at a constant velocity, then your average velocity is the same as your constant velocity. So this average velocity for the first one, remember that's defined as delta x over delta t. That's the definition of average velocity. There. Now this is for the first segment. So if I solve this for time, I solve it for time, then that's going to be delta x all over the average velocity, which in this case is the constant velocity. And that's going to be 250 all over 100, which is what? 2.5 kilometers per hour. Sorry, 2.5 kilometers over 100 kilometers per hour. That's 2.5 hours. Okay, so it takes her 2.5 hours to go north. She rests for three-quarters of an hour, and then to come south, I'm doing that one in green, so I'm going to figure out that time period, delta T3. Using the same equation rearranged, that's going to be delta X3 all over V bar 3. That is 100 divided by 50, which is 2 hours. Okay, so on this question, the first thing asks for the total time traveled. That is delta t total, and that's going to be equal to the sum of all three of these things, even when she wasn't moving. So that's 2.5 plus 3/4, or 0.75, plus 2. So what is that? That's 2.5 plus 3/4 is 3.25. Was that 5.25? I hope. Hours. Yeah. Okay. So she's gone for a total of this whole journey takes 5.25 hours. Okay. Next part. Change colors because we can. The total distance traveled. D. Now, distance does not take into account direction. She traveled 250 kilometers, and then she traveled 100 kilometers. So that equals 250 plus 100 is 350 kilometers. That's just how far that she had to pay for all that gas. It doesn't say anything about direction. She could have gone around in circles the whole time. It doesn't say anything about direction. That's just how far the car physically went. Okay. Total displacement. Now, displacement is it's still going to be measured in kilometers, but it's not how far you traveled. It's just comparing where she ended up to where she started. She ended up here. She started here. That is what? 150 kilometers north of where she started. She started here, 250 kilometers north, but then she backtracked 100 kilometers. 250 less 100 is 150. So this is comparing where she stopped to where she started. That's all it is. It's comparing where you stopped to where you started. That is, again, that's where, what is it? 250. No, it isn't. Bad teacher. I said that's 150 kilometers north. So that statement is that she ended up 150 kilometers north of where she started. Okay, I'm going to stop this because I'm going to run out of time, and I'll finish this on the next video.